Hello everyone. In today's video, we will see the solution of some MCQs related to the metals. So let's begin. In the first question, we have got a pieces of material are placed in turn between P and Q. We got this circuit and there are 2 points P and Q in the incomplete electrical circuit shown. Which material would not cause the bulb to light? So we need a material over here that does not conduct electricity because it's not causing this bulb to light. That means it should be a non-conductor of electricity. Aluminium is a metal that will conduct. A diamond is a non-conductor of electricity, so it won't. And magnesium and zinc, they're all metals. So we got a diamond, the answer, which will not cause the bulb to light. Which property is common to calcium, potassium, and sodium? Okay, calcium is in group number 2 of the periodic table, potassium is group 1, and sodium is also in the group 1. Their atoms all lose 2 electrons when they form ions. That's not a true statement because calcium will lose 2 electrons, potassium and sodium will lose 1 electron when they form ions. They all form carbonates which are insoluble. Remember, carbonates of sodium and potassium, they are always soluble. But remember, all salts, all compounds of sodium and potassium, they are always soluble. So that's also a wrong statement. Next, they all are less dense than water. Sodium and potassium, they are less dense and they float on water, but calcium is not. So it's also wrong. The last statement, they are all metallic. Yes, they are all metallic. That is true. Next, question number 3. Graphite shares some properties with metals. Which property of graphite is not one of the general properties of metals? Okay, graphite form a gaseous oxide. Graphite, is carbon, and when it reacts with oxygen, it forms carbon dioxide, and this is a gas. Okay. On the other hand, metals, when they react, for example, we got sodium oxide, we got like copper oxide. These oxides, they are all, or we got zinc oxide, they are all solid in state. They are not gaseous. So you can say A is a quality of graphite that it doesn't share, doesn't uh, common to the metals. Graphite is the conductor of electricity. Yes, graphite is a conductor of electricity. Metals are also. Graphite has a high melting point. Yes, graphite and metals both have high melting point and both are solids as well. In the next question, we got a table in which we got different metals and their melting point, density, and electrical conductivity is shown. They're saying which element is copper. Now, copper is a transition element, and transition elements, they have high melting points. Okay, so the high melting point that we have is only this one. They have high density as well and they are good conductor as well. So D is a right answer. Next question. The diagram shows the circuit used to test the electrical conductivity of strip of solid materials. If the materials conduct the bulb lights, strip of brass, nylon and zinc each are tested separately by connecting them with the circuit. For which strip does the bulb light? Okay, so we want some conducting material over here because the bulb will only light if the material used over here is a conductor of electricity. So brass is an alloy that will conduct, but nylon is not a conductor. Nylon is a plastic, doesn't conduct electricity. Zinc do conduct. So that's not the right answer. Brass and nylon will not. Nylon and zinc. So the answer is actually this one. The zinc and brass only that will conduct electricity and it will make the bulb to light. Next question. Which diagram best represents the structure of a solid metal? In the solid metal, we have positive ions and sea of electrons. Okay, A is not possible because in A we got only positive ions and negative ions. Okay, in the key they have given you. So B is a diagram in which you show the randomly moving electron, the randomly present electron. Actually, that is the correct answer. The metals, they are not arranged like this, that you have a layer of positive, then positive, negative, like this. It's not like that. And also not like this, that all positives, they are connected to one another and electrons are surrounding it. No. Number 7, which substance conduct electricity both when solid and when molten? So that has to be a metal or it should be an alloy, because alloys, they are the substance which conduct electricity, which have freely moving electrons in the solid state. That's why they conduct electricity. Hydrocarbons, they are covalent compounds. They contain hydrogen and carbon only, like we got CH4. They are non-conductor. Metal oxides, uh, they are like sodium oxide. In solid state, they don't have any freely moving electrons, so don't conduct electricity. Salts as well. In the solid state, they don't conduct, but when they are melted, they conduct. In the next question, we got element X has a lattice of positive ions and sea of electron. Lattice means a regularly arranged pattern of positive ions. So when you have a positive ions arranged regularly, you'll say it's a lattice. Which property will X have? Fine. It conducts electricity by the movement of ions and electrons. Metals, they conduct electricity by movement of electrons, but their ions, they do not move. Ions remain at their own place. It has a high melting point. That is possible because metals generally have high melting point except for, you can say, group 1 and mercury. It is decomposed by an electric current. Metals, when you pass electricity through them, nothing happens to them. They remain as it is. They are not decomposed. So that's not correct. It's not malleable. Metals are always malleable. Malleable means you can convert them into thin sheets. Metals are the substance which you can convert into thin sheets. All metals are malleable. Not malleable is a wrong statement, definitely. So we got B is the right answer, in which they have high melting point. Now let's move ahead and see some questions related to alloys. So alloys, they are mixtures of two or more than two metals, and they can contain non-metals as well. So let's see the questions. In the first question, alloys are usually harder than metals from which they are made. What which difference between the metals explain the greater hardness of the alloys? Look, alloys, they are hard than pure metals. It is because of the difference in their sizes. So the atomic radius is the correct answer. Densities, electrical conductivities has nothing to do with the strength of the alloys. You see in the next question, which diagram represents the structure of an alloy? So you see alloys, they are similar to metals. They have positive ions, they have sea of electrons, but the difference is that there are atoms with different sizes. You can see here the small size atoms and they are mixed with large size atoms. So B is the answer for this, that is an alloy. Let's see the next one. The diagram shows the structure of an alloy. Okay, which statement about alloy is correct? So alloy can only be formed by mixing copper and iron. No, we can make alloys from many different metals. High carbon steel. High carbon steel is an alloys, okay? And they are soft and easily shaped. Alloys, they are not soft and easily shaped. Alloys are strong materials. So it's not the correct statement. Next one. In an alloy, there is an attraction between positive ions and delocalized electron. Yes, that's fine. Alloys, they have positive ions and sea of electrons, and there is an attraction. The, the alloy brass has a chemical formula. Never. Alloys are mixtures. They are mixtures. They are made by mixing metals, by melting them and mixing them in a definite proportion. But they don't have a chemical formula because there is no chemical reaction involved in the formation of alloys. Which two statements about alloys are correct? Alloys are formed by mixing two metals. We can make alloys by mixing two metals. That's fine. Alloys do not conduct electricity. Alloys do conduct electricity because alloys, they have freely moving electrons present in them. Atoms in an alloy must all of the same size. No, alloys, they are stronger because they have different sized atoms mixed up together. In an alloy, there is metallic bonding. Yes. So we got option number 1 and 4. So answer is B. Which structure represents an alloy? So we have done a question like this before, that atoms of different sizes, there must be positive ions of different sizes present, and there must be electrons. So electrons are present in A, B, and C. A contain all atoms of the same size. That's not right. B contain ions, but they are randomly arranged. That is not possible. Again, in C, you see we have small ions, bigger ions. They're all mixed up together, and there are electrons present. So C is an alloy. D is not an alloy. What is D? D is actually an ionic compound because it has positive ions, negative ions. Positive ions, negative ions arranged in a lattice. Let's move ahead. The diagram shows the structure of brass. This is brass. Why brass is harder than pure copper? And I think till now you must be able that it's all because of the difference in the sizes. Okay, the sizes of the atoms, different sized atoms, they prevent them from sliding over each other. So we got the answer B, in which you see zinc atoms prevent the layers of copper from slipping over. There are no covalent bonds present in the metals, and sea of electrons, they do not, you can say, prevent them from moving. Actually, the layers prevent it because of the different sizes. What's the structure of an alloy? Again, the similar one, different sizes. A. Metals have a structure of positive ions and a sea of electron. Metals are malleable because it is possible to force ions to slide over each other. The alloy brass is dash malleable than pure copper. You know, they are less malleable. Brass is dash to conduct electricity. Brass is an alloy, and alloys, they contain freely moving electrons, so that will be able to conduct electricity. So B is a correct answer. Brass is an alloy. Which statement about brass is correct? So we are so it contains sea of electrons. Yes, it contains positive and negative ions. It contains positive ions but does not contain negative ions. It contains rather electrons. It is a compound of metal non-metal. No, it's not a compound. It's a mixture. It is compound of two or more metals. It's not compound, mixture. So we got A is a correct answer. Which statement about alloys are correct? Similar question. So these were some questions from alloys. Now let's move ahead and see some questions about the reactivity of metals. So let's move ahead. In the first question, from the knowledge of your manufacture of both aluminium and iron, what is the order of chemical reactivity of aluminium, carbon, iron towards oxygen? Okay, if we got metals, aluminium is the most reactive, carbon is the next one, and iron is the next one. You should know the reactivity order of the different metals. So here we got the list of metals according to their decreasing reactivity. Potassium is at the top and it's the most reactive metal, while platinum is the least. And as far as non-metals are concerned, we can put carbon over here, and we can put hydrogen present over here. Now let's move ahead. The list shows some properties of metals. Mercury is a metallic element. Which of these statements is not applied to mercury? Okay, mercury is a liquid element. So metals are good conductor of electricity. Yes, mercury as well. Metals form ions by loss of electrons. Yes, they form, and mercury as well. Metals have high melting point. Metals have, but mercury do not have the high melting point. So it's the statement number 3 that does not apply to mercury. Metal M will displace copper from aqueous copper sulfate. Okay, it is possible if M is more reactive than copper sulfate. Okay, so you can say M is more reactive than copper, but will not displace iron from iron to sulfate solution. So you can say M is less reactive than iron. So an M is extracted from its oxide by heating the oxide with carbon. So that means you can say M is less reactive than carbon. So we can arrange the metals, arrange the metal M. Now let's see least reactive. We can arrange the metals looking at the information given. So least reactive, it would be copper. Okay, and then you can say metal M is more reactive than copper, but it's less reactive than iron. So metal M is less reactive than iron, so it would be like this. Sodium is the most reactive. So D is the correct answer for this question. Number 4. Aluminium is higher than copper in the reactivity series, but the following reaction should be feasible. The reaction does not take place at room temperature. Why? This is the reason. Actually, this is because of aluminium. Aluminium, is reactive metal, but under normal conditions, it has got an oxide layer. And this oxide layer, it prevents it from reacting, because the oxide layer is non-porous. Like we got this piece of aluminium, and over this aluminium, you will have a thin layer of aluminium oxide. Here we got aluminium, and the outer layer is aluminium oxide. This oxide layer is non-porous. That means air and water, they cannot pass through it. That's why the aluminium inside, it remains unreacted. It remains intact. So it's a protective layer. So aluminium has an inert coating over it. It's fine. That is the correct answer. Fine. Let's move ahead. Which row shows the three metals in the correct order of decreasing reactivity? Okay. So most reactive. Most reactive is from copper, iron, and zinc. We got zinc is the most reactive out of these, then the iron, and then the copper. You have to learn the reactivity order that I have just mentioned in the previous questions. Again, the similar one, we have the most reactive to the least reactive. The problem in that most reactive is calcium, and then magnesium and silver. Aluminium and copper are often used to make coins, but iron is not. Okay, iron is not used to make coins. Why this is so? Iron is above both aluminium and copper in the reactivity series. That is wrong. Iron is below aluminium in the reactivity series. Iron is more expensive than aluminium. No, iron is less expensive than copper. Iron is rarer. No, iron is not rarer. Iron reacts with water. Yes, that's the answer. Because if you make a coin with iron, that will react with water. So we don't want the coin to react with water. A powder mixture of metals contain aluminium, calcium, silver, and iron. Excess HCl is added until no further mixture dissolves. What is the undissolved residue? So we have got the aluminium, the calcium, the silver, and the iron. So remember that metals which are more reactive, they react with acids, dilute acids, and metals up to uh, lead in the reactivity series that I have just mentioned in the previous question, metals up to lead, they react with HCl, and silver, they are below the copper in the reactivity series, so silver does not react with HCl, so that will you get as a residue. Residue means that is something that is present in the solution and that is insoluble. Fine. Let's see the next one. The following facts are known about four metals P, Q, R, S. Fine. So R displaces both P and S. So you can say R is more reactive than P and S. Q reacts with water, but R does not. So you can say Q is more reactive than R. S does not react with acid, but P does react with acid. So S does not react, that means you can say S is less reactive than P. Now using this information, they're saying what is the correct order of reactivity, the most reactive first. So you can see the most reactive. R is more reactive than P and S. Okay, so R has to be more reactive than P and S. Uh, so that is the only option that we have in which the R is more reactive than P and S. And you see that Q is more reactive than R as well. That is fine. So B is the correct answer. Look at this question in which we got three different diagrams. So they are asking which are metals W, X, and Y. So you see in W, in this the first reaction, in the first test tube, there is no bubbles formed. So it means the metal is unreactive. So unreactive metals that do not react with dilute acid, that is copper. Metal X. Now what is the difference between the two X and Y? You see the number of bubbles. There are more bubbles present in the metal X solution, while in metal Y there's a less bubbles. So you can see metal X is more reactive. So more reactive metals is magnesium, and then we got the zinc. Answer is A. The element chromium liberates hydrogen from dilute HCl. Okay, liberates hydrogen, that means chromium is the reactive metal and react with dilute acid and does not react with cold water. Fine, does not react with cold water. Remember, we got sodium, we got potassium, we got calcium are three metals that react with cold water in the reactivity series. So when a piece of chromium is placed in lead nitrate, crystals of lead appears. What does it mean crystal of lead appears? That means there is some reaction going on, which means that chromium is more reactive than lead. So you can say chromium is more reactive than lead, while chromium react with dilute acid but does not react with cold water. That means chromium is less reactive than these metals. Fine. So we have to predict the decreasing reactivity order. Fine. So you see chromium is more reactive than lead. Okay, so lead is over here at the end, lead is over here at the end in these two options. And then they're saying that chromium does not react with cold water, so we can say chromium is less reactive than calcium, and calcium is the most reactive, so A would be the correct answer. Okay, in the next question, we got which method will be used to extract metal M from its ore. Here we got the metal M, and metal M is present high up in the reactivity series. And these metals like sodium, potassium, and aluminium, these metals, they can be extracted from their compounds using electrolysis. So it would be the B is the correct answer. When zinc is dipped, added to a solution of metal sulfate, metal is deposited. What does it mean metal is deposited? It is because that zinc is more reactive than this metal. Okay, so that's why the zinc has displaced this metal and there is a metal deposit on the zinc. And zinc ions are produced, which is the metal deposit. So when we add zinc metal to another metal sulfate. The metal sulfate, it has to be less reactive metal sulfate that the displacement reaction can take place. So the less reactive metal than zinc is the copper. Four metals and hydrogen are arranged in decreasing reactivity. Which statement about these elements is correct? So aluminium is formed when aluminum oxide is heated with hydrogen. It's not possible. Hydrogen is less reactive than aluminium. It cannot displace aluminium from its oxide. Copper displaces zinc. Copper cannot displace zinc because copper is less reactive than zinc. Copper is formed when copper oxide is heated with hydrogen. That is fine because copper is below in the reactivity series than hydrogen. So hydrogen can displace copper oxide. We got copper oxide, and when you react it with hydrogen, hydrogen will remove oxygen from this oxide and make it copper. So in the next question, which metal oxide will be reduced by heating with iron? Iron should be the more reactive than the metal oxide. So calcium is more reactive than iron. Iron cannot displace. Magnesium cannot be displaced. Zinc cannot be. Lead is a less reactive metal than iron. It can displace. So let's see the next question in which we got different elements Q, R, T, Z. Which statement is correct? Q is a metal. Okay, so proton number 9, its electronic configuration will be 2 and 7. So 7 electron outermost orbit is not a metal. Okay, Q is more reactive than T. Q is 9 and T is 17. 17 means it would be 2, 8 and 7. So 2, 7 is fluorine, 2, 8, 7 is chlorine. Fluorine is more reactive than T. So that would be fine. Let's see the next one. R is more reactive than Z. So R is 11. 11 is 281, that is sodium, and it's 2881. Z is 2881, that would be potassium. So Z is more reactive than R. R is more reactive than Z is wrong statement. So in the last statement, T and Z are in the same period. T and Z in the same period not possible because T got 3 shells and Z got 4 shells. Z is in the fourth period, T is in the third period. So that's wrong. So answer is B. In the next question, the result of experiments involving four metals W, X, Y, Z are shown. We got this, and we have to predict the order of reactivity. Most reactive to least reactive. Fine. So in these reactions, you see Y reacting with Z, and there is a reaction. So you can say Y is more reactive than Z, and W with X is no reaction, means W is less reactive than X, and Z plus X ions, there's a reaction taking place. We can say zinc is more reactive than X. Okay, so the least reactive that we get is W. So if you just go with the least reactive, most reactive, least reactive, we get this answer C, because the only least reactive metal that we got is W. Now let's see some questions related to the thermal stability of metal compounds. So the first question, which substance leaves a black solid when heated? Black solid is actually copper oxide. So the answer would be copper carbonate, that will leave a black solid. Otherwise calcium oxide is white solid, potassium, zinc, they're all white solid. Metal carbonate decompose when heated. Which carbonate is most stable to heat? Remember, more reactive metals, they form more stable compounds. So in these options, we got calcium, copper, lead, and zinc. So if you see the reactivity of these metals, we find that calcium is the most reactive metal in all of these. So that's why it will form the most stable compound. So A is the answer. The carbonate of metal X is a white solid. Okay, white solid. Decompose when heating. Fine. Carbon dioxide and a yellow solid. Yellow solid is formed. So oxide that has got the yellow color is only one, and that is the lead. You should know this, that yellow lead oxide is yellow in color. Copper oxide is black, iron oxide is red brown, sodium oxide is white. Solid Y is insoluble in water. It gives off a gas when heated and also when reacted with dilute sulfuric acid. What is Y? Okay, so we got a compound that is insoluble. Sodium nitrate is soluble, sodium carbonate will be soluble. Now we are left with two. Copper carbonate, zinc oxide, they both are insoluble. It gives off a gas when heated. So gives off a gas when heated. So it would be copper carbonate, because zinc oxide, it cannot give you any gas when heated. It do not decompose. So A is answer. So we are done with these questions of thermal stability. Now let's see some questions upon the metal displacement reactions. So in the first question, a coil of clean copper wire is suspended in aqueous silver nitrate. So copper wire, copper is more reactive than silver. Okay, we got silver ions present in the solution. Crystals of silver are deposited onto the copper wire. Definitely there is a displacement reaction going on, which statement is not correct. Copper is oxidized. In this reaction, copper change into copper ions. Because copper has a greater ability to lose electron, it will lose electron more easily, and loss of electron is oxidation. That is a correct statement. Total mass of crystals of silver increase gradually, because as the reaction proceeds you will get more and more silver get deposited, so that is fine also. Total number of positive ions in the solution are unchanged, so that statement needs to be carefully looked at, because copper become copper ions and by the loss of two electrons. On the other hand, silver positive ions, they gain one electron to form silver. So if you balance this, because copper they are losing two electrons and silver is gaining one electron. If you balance writing two here, so what we get? We get, for if there are one ion is being added in the solution, there are two ions which are going out of it, because copper lose two electrons, silver gain one electron. So that's why we can say total number of positive ions that do not remain unchanged. They are actually decreasing in number. So C is the answer. That is not correct. The solution turns blue. Yes, it turns blue because of the copper ions. In the next question, an experiment is carried out to find out the order of reactivity of some metals. Three metals are placed in solutions containing aqueous metal ions. So we have dipped magnesium, iron, and zinc in all these ions. So you see, magnesium, it has made all the reactions. So you can say magnesium is the most reactive. So magnesium is the most reactive, while there is no reaction for iron. So you see, iron hasn't displaced any of these metals, so iron is the least reactive of them. So we can say the answer is C. And you can also see that zinc, it has not displaced aluminium, and zinc is less reactive than aluminium, so that's why aluminium is more reactive. C is a correct answer. So the next question, what is the ionic equation for the reaction between zinc and aqueous copper 2 sulfate? The ionic equation represents the ions and the atoms, elements which are directly involved in the reactions. We have zinc. Zinc has to be in the solid state. So option A and B both are wrong. C, we got zinc in solid state, but in C, we got copper sulfate. It's not ion, it's a compound. So copper ions has to be there, and which zinc, which replace copper to form zinc ions in copper. D is a correct answer. What happens when zinc foil is placed in aqueous solution of copper sulfate? Yes, Zinc is more reactive than copper 2 plus ion. So we got, if you have got zinc, in the previous equation we have just seen this, that zinc converts the copper ions to copper atoms. So copper ions are oxidized. Copper ions actually they gain electron. When they gain electron, that is they are reduced. There is no reaction, that's wrong. Reaction takes place. Zinc atoms are oxidized. Yes, this happens because zinc atoms change into zinc ions. So in the next reaction, we got three different metals, rod Z, W, and X, and they're saying in beaker 1, metal W is displaced from solution. Metal W is displaced, that means Z is more reactive than W. In 2, X is displaced, that means W is more reactive than X. And metal in 3, Y is displaced, so X is more reactive than Y. What is the order of decreasing reactivity of these four metals? So from the information we can say that Z is the most reactive and Y is the least reactive. Fine, but what about W and X? You can see W is more reactive than X, so W is more reactive than X. C is the correct answer. Metal X oxidize in air. The formula of oxide is XO. The X has to be a 2 plus ions. X displaces zinc from zinc nitrate. That means X is above in the reactivity series than zinc. What could be X? So above zinc, which metals we have? We have potassium, sodium, calcium, and magnesium. These are the metals which are present above zinc, including aluminium. Now it should be 2 plus. Aluminium is not 2 plus, 3 plus. Lead is below in the reactivity series. Magnesium is fine. Sodium is also not possible because it is 1 plus. So answer is C. Okay. What happens when a strip of silver is immersed in aqueous copper sulfate? The silver is a less reactive metal, so there should not happen any reaction. Bubbles of gas appear? No. No reaction occurs? Yes, that's fine because silver is less reactive. Aqueous copper sulfate is placed in an iron container and left for several days. Now, iron is more reactive than copper, so there should be some reaction. Atmospheric oxygen react with copper sulfate. Actually, copper sulfate does not react with atmospheric oxygen. There is no reaction like this. Some fine iron particles are formed in the solution. Actually, we get iron ions. Iron particles, they are not formed. The part of the container in contact with solution is coated with copper. Okay, you see copper is a less reactive metal, iron is more. So iron will displace copper. That's why you will get a coating of copper where the iron is in contact. That is fine. The solution turns from green to blue? No, because copper sulfate is already blue in color in the beginning, so it's not green. So C is answer. Which pair of reactants will undergo a displacement reaction? So we must have a more reactive metal reacting the less reactive one. That is wrong because silver is less reactive. Copper is less reactive than magnesium, not possible. Magnesium is less reactive than calcium, not possible. Zinc is more reactive than copper, that is fine. Metal M is displaced from aqueous metal nitrate by copper. Okay, metal M is displaced by copper. That means the metal M, it has to be lower in the reactivity series than copper. Okay, so which statement about metal M and its compound is correct? M carbonate is stable when heated. Okay, so M is displaced. So M is very below in the reactivity series, and you know, as you go down, the metal carbonates become thermally unstable. So it's stable to heat. That is wrong. So metal oxide is reduced by M on heating with carbon. Okay, carbon you see is above in the reactivity series, and the metals which they are talking about is below copper. That means the metal is one of these metals. So metal oxide is reduced by heating with carbon. Yes, it is reduced. Metal reacts with dilute HCl. No, metals do not react. Metals below copper and including copper, they don't react with dilute acid. It's wrong statement. Metal M reduces zinc oxide to zinc. No, it cannot do because it's a less reactive metal. So we got answer B. So in this video, We have seen questions related to the metals, the thermal stability of metals, the reactivity of metals. Hope you have understood all these questions and you will be able to solve them. We will see some more questions and topics. Till then, goodbye.